Thank you all for joining this webinar on the title Unlocking the Potential of GenAI and Agentic AI in Rail Asset Inspection and Maintenance. Before we start, I want to introduce myself. I'm Sandeep and I lead the rail industry practice at Tata Elxsi and drive strategic initiatives at Tata Elxsi for the rail business. I'm also joined by my panel member from Tata Elxsi for the Q&A session, who would be Rajesh, who is a senior solution architect at Tata Elxsi. As we all know, AI continues to be in the news all the time nowadays. There is so much of development happening in that space that it is now quite difficult to keep pace with it. Some industries are early adopters, but eventually this will impact every industry, including the rail industry. This webinar looks at how GenAI and Agentic AI can be leveraged to further add value to the technologies which are increasingly getting adopted in rail industry, especially the machine learning and computer vision technologies in the rail asset inspection and maintenance. Today's webinar is planned to be around 35 to 40 minutes, followed by discussing some of the questions which we have received from participants who have registered for this webinar. We may not have the time to take all of the questions, but you can reach us through our website as well as the email link, which I will share at the end. Before I start, I want to share the flow of the content of this webinar. I will start with a quick introduction of Tata Elxsi as a company and what we do in the rail industry. We will then have a quick look at the wide variety of the rail assets which are inspected by maintenance teams in rail industry. This will also help understand the context of the webinar in terms of how digital solutions are developed for rail asset inspection and how technology is evolving, especially with the rise of GenAI and Agentic AI. At the end, I will also cover some of the work, what we have done in the industry pertaining to GenAI and Agentic AI. Now let's have a quick introduction of the Tata Elxsi as a company which I represent. Tata Elxsi is part of the $180 billion business conglomerate Tata Group. Tata Group has presence across almost all industry verticals with a total combined employee strength of more than 1 million across all its companies. Tata Elxsi was established in 1989 and is headquartered in India with operations in all the major geographies in North America, in Europe, as well as in Asia Pacific. With a team of over 13,000 designers and engineers, we provide product design services and develop digital solutions for our customers in primarily the transportation verticals, that is rail industry, automotive, off-highway, and aerospace. We also have a presence in media and communications vertical as well as the healthcare vertical. Our revenue for the financial year in 2025 was $440 million. And now I will talk about what we do in the rail industry in the next slide. Tata Elxsi has been working in the rail industry for more than 12 years, and our customer base includes rail operators, railroads, rail infrastructure managers, and train manufacturers, and as well as the system suppliers. We work with rail operators, railroads, infrastructure managers to design and develop digital solutions to automate operations, especially for the rail asset inspection and maintenance. Moving on to the right on the top, we also work with train manufacturers and equipment manufacturers in the design and development of perception systems as we leverage technologies for object detection, sensor fusion for collision detection and inspection. We have a legacy of being a core electronics embedded systems company, and that is the experience we leverage in developing safety critical systems for system suppliers, supporting projects all the way up to sell for maturity, including cybersecurity requirements. On the bottom left, we work also quite heavily with train manufacturers where we leverage a mature systems engineering approach to reduce the product development time to help our customers develop new trains and systems faster. We also bring a lot of experience and expertise in doing industrial design, interior design for our trains, which we develop for our customers. Moving on to the digital solutions, we have a strong focus on developing digital solutions to improve passenger convenience, yard safety and monitoring, yard operations, and predictive maintenance. Finally, we develop digital solutions leveraging the power of GenAI, Agentic AI, and have also incubated a small practice in Turtlexy with quantum computing as a new technology front. Overall, we have a talent pool of more than 300 core engineers in rail domain with multiple projects delivered over more than 12 years. In this webinar, I'm going to focus on rail asset inspection and maintenance and around the technologies areas of GenAI and Agentic AI for rail asset inspection. This slide is to convey the various scope areas associated with rail asset inspection in rail operations. Broadly speaking, I have clubbed the assets type into four categories: rail tracks, including various components making up the rail track, then the rolling stock, including locomotive, wagons, and trains, yards, including various types of yards, whether it is called as a hump yard or a depot or siding, depending on the region as it is called. And the rest of it is clubbed under the category wayside. The inspection systems are typically looking for issues associated with geometrical aspects of the assets to check whether the geometry is correct as per the standard or design. Or they are checking for completeness, whether something is missing or loose. Or they are looking for damages such as cracks, breakages, or the count of certain parts is different to what is acceptable. Additionally, one may also be looking at other aspects pertaining to surveillance for theft monitoring or cleanliness or spillages or for yard operations. When it comes to onboard systems, we're talking about traction motors, batteries, brake systems, which also needs to be monitored as well. I have shown some scenarios here under the four broad categories, but the list of scenarios is much larger in the real world. But it represents the scope areas where an automated machine vision solution adds value. Some of these assets can be fully inspected using images, and some others may require some additional sensory data. Rail networks and assets are critical infrastructure for any country. To ensure the rail operations are efficient, safe, and continuous, it is essential to ensure the high availability of these assets. A big part of the budget of the rail infrastructure managers, railroads, and operators goes into rail asset inspection and maintenance. As you can see in the slide, 40% of the total cost of ownership of rolling stock is for maintenance of the rolling stock, as the rolling stock itself lasts for more than 2 decades, running into 3 decades or even more in some cases. Similarly, rail infrastructure consumes anywhere between 30 to 40% of the operational expenses across Europe, as per the consultancy report mentioned there. In North America, US freight railroads also spend a sizable amount for inspection and maintenance of the world's largest rail network. Because of the critical need to maintain these assets, the rail industry has been steadily investing in new technologies to reduce the cost of rail asset inspection and to reduce the cost of asset downtime. This slide conveys how technology introductions are evolving in the rail industry. Around the 2000 time frame, increased sensorization of the rail assets enabled development of remote condition monitoring of the assets, and also the development of the computer vision based solutions started around 2020 time frame. With the advancement of the traditional machine learning technologies, which going forward I will also abbreviate as ML, the industry saw a lot of new development which leveraged the power of machine learning models along with traditional computer vision techniques to develop more accurate inspection systems. Some of the key benefits the machine learning models powered vision systems introduced were around the accuracy improvement in detection of the various types of faults, easier scaling of the solution to handle different faults, and the ability to process data in almost real time on the edge device itself. Please note that with machine vision inspection solution, it was now possible to take one image and detect various parts in that and as well as the various faults in that, as not all parts and components for the various condition can be sensorized, as that will be too cost prohibitive and in fact engineering wise also very unfeasible. In this slide, I'm showing the typical life cycle of a development of AI ML, that is machine learning model powered asset inspection solution. To start the process, it starts with the collection of the data from the real field. And when I say data, I'm talking about images. One has to collect sufficient data for both good order conditions as well as bad order fault conditions. This is required to create machine learning models which can differentiate between good and bad conditions of an asset. The next step is in the middle, as you can see, is to train the machine learning models so that they can achieve the required accuracy of detection or inference. Once these models are trained and have reached the required performance in terms of accuracy, they have to be deployed on the production system. And then one has to monitor the performance of these models as well as the solution deployed on a continuous basis. The data coming from the real field can change due to various factors such as environmental conditions like rain, snow, or change in the sunlight. It could be as a result of change of assets, which the details of which can change from site to site, from yard to yard, or due to other technical reasons. Finally, all the process data of the inspection resides on the cloud or edge device for querying and for creating reports and dashboards. While the process of developing and deploying machine learning models is well established using traditional ML models, it also brings many challenges, which is what we are going to discuss in the next slide. In this slide, we look at the various factors which are associated with traditional machine learning models-based approach. These are the factors where introduction of GenAI brings additional value over machine learning model-based approaches. Machine learning models-based approach need a large data set to train machine learning models to achieve the acceptable performance accuracy on the top left, as you can see. This means a lot of time and effort is spent on generating the required data set or collecting it. Moving on to the top right, another challenge is the need to have the defect data as well to achieve the required accuracy in detection of fault conditions. Collecting fault conditions data is time consuming, costlier, and in some cases almost not practical considering the day-to-day service operations which must take place without fail. The other challenge on the second row from the top left is the machine learning models also struggle with rare anomalies and don't really handle the variability in asset conditions without extensive training. For examples, an ML model developed for detecting a fault may not give the same result for an image of the same asset when captured in the bright light condition versus the same image, the same asset when it is captured in a low light condition. So there is limitation in domain adaptiveness in ML models generally. The other point to highlight here is the ML machine learning models architecture is typically very rigid, as typically the ML models, which is what I call as machine learning models, are developed for a specific task. This means there is a need for creating and training a very large number of machine learning models for the various asset inspection solutions which have to be developed to handle various defects. Then the point I want to talk about is once the ML based powered solution gets executed, one has to spend efforts to create extensive set of queries and derive meaningful data from the execution output. And it usually means one needs to have IT programming skills to create those queries and to create those dashboards. Lastly, there is sizable effort required in data preparation and data annotation while developing solutions which are powered by machine learning models. These are some of the key areas where GenAI adds value, which is what we will cover in the next few slides. Having said that, the value of the current traditional AI/ML model-based approach along with computer vision still holds a lot of value and will continue to be there. But there are certain areas where GenAI will add additional value to the rail industry. And that's what we're going to discuss in the next slide. In this slide, I want to introduce the two new terms, which is the core of what this webinar is all about, GenAI and Agentic AI. As per the definition, GenAI is a technology which creates new content such as text, audio, data, or does inference. GenAI can be used typically for synthetically creating data, automating the image enhancements such as pre-processing, annotation, and is also easier to generate reports as it is easy to use a natural language as an input and its ability to summarize complex technical information based on the context. On the other hand, agentic AI does not create anything as such. What it does is an agent or a set of agents, given a goal, they make decisions in a dynamic, iterative environment to achieve those goals. And in turn, they can use other GenAI models or data sources while they are meeting their objective and goals. The AI agent-based architecture is best suited for multi-step workflows in repetitive tasks and in the orchestration of various integrated business processes. In the next few slides, I will delve more into where GenAI adds value in development of vision-based asset inspection, and also cover in brief where agentic AI approach can be used post-inspection when it comes to completing the various business processes as part of the maintenance lifecycle. In this slide, I'm sharing an overview of the broad areas where GenAI adds value, either in the development of the rail asset inspection solution or when using the rail asset inspection solution when it is deployed. During development, GenAI can be used for requirements generation, test case generation for developers for developing the application itself. During development, GenAI can also be used for generating synthetic image data for training as well as for testing. GenAI can also be used to automate the annotation of the images and for introducing enhancements, changes to the data to bring the variety of real-world context and nuances, which is very much required when performing various asset inspection and still deliver high accuracy. During development, GenAI models reduces the effort and time in developing solutions because of the capabilities which GenAI offers. For example, few shot learning, which is where a few examples of the real asset is all what GenAI needs to learn versus a larger data set required for a traditional machine learning model. When it comes to report generation, GenAI can be used like what we are already used to using with Copilot, Gemini, and ChatGPT as an example, where to express our intent is all what it takes in the form of a natural language, and the GenAI can give us an output or a report as we want. And that makes it very easy for all spectrum of users to use GenAI powered applications. Agentic AI or use of AI agents also holds value when it comes to integrating the various business processes which must come together post inspection to complete the life cycle of the support ticket raised for closing the actions. We shall look into it in a slide later. This slide is an expansion of the development and deployment of the real asset inspection solution where GenAI can be deployed. As you can see in the whole process, there are multiple stages or blocks. And there are some areas where GenAI can add substantial value over traditional ML, and in some areas where the applicability and the usefulness of GenAI is still evolving. As we saw in the earlier slides, areas like synthetic data generation, areas like training the models are some of the key value additions which GenAI bring to the table. Having said that, as GenAI continues to evolve along with AI agents, it is expected to bring more and more value to the real asset inspection solutions during its development as well as during its deployment. And GenAI will continue to evolve following the experiences and learnings from other industries. Overall, based on the work Tata Elxsi has done and what we are doing currently, we are seeing significant reductions in the development effort, thus bringing down the cost of developing the asset inspection solutions. In this slide, I want to talk about a bit more about the AI agents with respect to where do they fit into the whole scheme of asset inspection and maintenance. What I want to highlight here is the typical processes. Not all of the processes are shown here, but some of the key ones I've just mentioned, which gets initiated once an asset has been found with a defect. And then that requires a response from the maintenance team. Once the issue is raised for a defect, a work order or a support ticket is raised, which needs to be assigned to a maintenance technician. That assignment depends on the availability of the technicians on a given day at a given site. Additionally, if the part which is to be replaced requires a replacement, then one has to check in the inventory system if it is available. And if it is not, then one has to initiate the procurement of the same. So based on the priority of the defect, one has to coordinate with traffic controllers to find repair slots during the calendar when the asset can be repaired or serviced without impacting the safety of the workforce or without impacting the operations which is happening on the line. Some of these processes are safety critical in nature and therefore definitely require human oversight or human direction. And then there are those which can be automated, especially using AI agents without impacting safety. For example, triggering the request, checking for the inventory system if a part is available. And if it is not, triggering a purchase order or a procurement process to procure that part is something which does not have any impact on safety. And therefore, AI agents can take that up quite naturally. By leveraging the power of AI agents, time to respond to an incident can be reduced by automating the non-safety critical links in the whole process from finding a defect to fully resolving and documenting the closure. AI agents are being deployed in other industries and in functions such as supply chain management, which is quite a dynamic environment. And thus, it holds potential for use in rail industry as well for select processes. In this slide, the dark blue blocks are where I have projected where AI agents may be introduced for automation, where safety is not impacted. In this slide, I'm summarizing the benefits of using GenAI in development and usage of the rail asset inspection solution. GenAI reduces efforts and therefore the cost associated with data creation and data preparation. It's easier to use by maintenance teams through prompts, just like as what we use on a day-to-day basis with some of the GenAI tools like Copilot, Gemini, etc. GenAI enables faster performance in many cases and generally improved accuracy over machine learning models based architecture, depending on how it has been trained. Lastly, and equally important, is that it takes less effort and cost to upgrade GenAI based solutions over the life of the solution. The traditional ML models, once they're deployed, they take a lot of effort and cost and retraining compared to what it takes for GenAI based solutions to do that. So while traditional machine learning models based architecture will continue to be relevant, the important thing to note is that GenAI adds additional value over and above that. So while we are talking about the potential for generative AI in asset inspection and maintenance, it does present a lot of exciting opportunities, but there are also hurdles and concerns which must be looked into as we move forward. GenAI based architecture are technically more challenging to build and develop. And of course, they require high computational requirements to execute. In order to execute them on the edge device, attention needs to be given to fine tune them to run on the edge devices without impacting accuracy. So there is a trade off to be looked into to decide whether to execute something on the edge versus something on the cloud. As with other industries, data security and privacy is another area to be aware of when developing and deploying GenAI based solution on the cloud. Like machine learning models, there is limited explainability when it comes to audit of how the solution works and what inferences it draws from the data. There's more research which is ongoing to give audit perspective more clarity in terms of how the system works. The data used in training and updating the GenAI also needs to consider the bias to ensure that it is not error prone. So one has to focus on making sure the right set of data and the right quality of data is fed into the GenAI models. Lastly, developing GenAI based solutions requires skilled resources, whereas the usage of GenAI based solutions may be more easier. These factors, which I mentioned, are not exhaustive, but are the key ones to be closely studied when companies decide to develop and deploy GenAI based solutions. Now, we shall quickly look into some of the work Tata Elxsi has done in the space of GenAI and Agentic AI. So, Tata Elxsi developed a GenAI based synthetic data generation tool called GenVision for images. This tool allows the developers to create the required data set with all the variations, defect conditions to reduce the time and cost of generating the right quality of data. This we have used it in some of our projects in the rail industry as well. And as I mentioned, the cost and time for generating all kinds of data, including especially the defective data, is quite cost prohibitive and time consuming. And that's where this tool adds a lot of value when it comes to that. The second in the middle is where we developed a GenAI prompt-based tool called Prompt Vision for visual inspection of images and videos, where users can put in their query and get all the data which is there in the images using GenAI models. For example, you can query the ID of a car in a video of a series of wagons passing through it. Or you can ask if a door of any wagon is shut or open. Or you can also count the number of instances of a part, for example, how many wagons are there, of what type in a given video of a freight train. We have also developed a GenAI based conversational app for technicians, which can be used by technicians as well as the users to interact with the equipment for diagnostic purpose. For example, the technician can interact with the equipment through text or voice or give images to understand the faults quickly. And the tool also provides steps for resolution, thus decreasing the time of diagnostics. This tool, what we had already developed, has now is already being used in automotive industry, but the same tool can easily be used in the rail industry for diagnostic of critical subsystems. Totalexy also developed a GenAI and Agentic AI framework for assisting developers when they are developing software, and that software can be used in any industry, including rail industry. Given the requirements, the tool can generate the various documentation across the stages of development. This tool also uses AI agents to achieve the required code quality and meet the required standards. And this tool is already in use with some of our customers. For a mining equipment, we did a project for developing a GenAI based tool for inspecting the excavating bucket, including the teeth. This helped the customer to reduce the number of unexpected downtimes by early discovery of the potential problems with the excavator tooth and the bucket. The last, what you can see on the slide, is an example of a GenAI based solution which we are developing internally for detecting the various cracks in the rail wheel. As you know, the cracks in rail wheel can happen in different parts of the wheel and can have different shapes and sizes. So there's a lot of variety of the data which actually needs to be collected if you are developing it based on machine learning model based approach. And that's why we are exploring how GenAI can be used to reduce the time and cost of development of a solution which can give the required accuracy. These solution accelerators, what we have shown here, helps reduce the time and cost of development of solutions for our customers, as we can customize these accelerators as per customer project requirements. With this, I come to the end of my presentation, and now I will introduce my colleague Rajesh R, who is part of the panel, to join the presentation for handling some of the questions what we have received from the attendees who registered for this event. Rajesh.
Hello.
Okay. So, due to the shortage of time, I will not be able to take up all the questions shared with us. And if you are not able to answer all the questions, you can contact us through our website or reach us at the email as shown on the slide. So with this, I will start with some of the questions what we have received through registration. Okay. So I'm just looking at the questions which we have received. The first question which I can see here is how is GenAI used in the inference for inspection solutions? And Rajesh, if I can request you to answer that.
Yeah, as Sandeep explained, there are multiple ways GenAI can be applied to in the development activity, including the solution. When we say the solution, the exact algorithm which is doing the inferencing part, we are using the basic building blocks of GenAI, which is having very good inferencing capability for finding the solutions. And basically, the basic building blocks like the transformer models, we are customizing and integrating with our solution, and that will be generating the accelerated performance.
Thanks, Rajesh. Um, you can see another question. Yeah, can the implementation of GenAI-based solutions and AI agents for asset inspection can it be supported on a hybrid system with a mix of both on-premise and cloud? Rajesh, would you like to take this question?
Yes, yes, yeah. Yeah, see, our solution, it can be deployed in any combination of infrastructure, and from starting from the lightweight simple computers to high-end GPUs, and with extending to the cloud infrastructure.
Okay. Yeah, so basically, yes, it can be deployed in a hybrid approach with some part of it running on premise and some part on the cloud. Is that right, Rajesh?
Yes,
That's
yes.
what you. Okay. And there is one question I have, that what tools are you using for developing such solutions? I am assuming it is referring to GenAI based solutions. Or what tools? Rajesh, would you like to share some tools what we have used in some of the projects in the past?
Yeah, tools mainly. We are not using any off-the-shelf or third-party tools for the entire solution development. But GenAI is getting used for integrated with other tools for generating the synthetic data set. Then for customization of the transformer model, we are using our own framework.
Okay.
Hope that answers.
Right. So we use transformer models and we customize them for the kind of projects what we do, as well as for the solution accelerators what we develop. Right. Okay. So there is a question: are GenAI models like ChatGPT, Copilot, can these models be used in real asset inspection? Maybe I can answer this. See, Tata Elxsi has not used these models yet for real inspection, and we believe that some of these can be used for certain inferences, not really for all the kind of solutions or problem statement which exist in the real asset inspection field. But this can be further explored, but we haven't used yeah, in our project so far. There's a question: does this GenAI solution require high-end servers or specific platforms? Rajesh, would you like to take that
Yeah, I
up?
think that we discussed the solutions can be deployed from normal computers to high-end machines, and depending on its execution time, and we will be able to deploy in low-end machines or high-end GPUs. Depending on this, I mean, severity of this problem, what we are analyzing, we can consider the deployment at different platforms.
Thanks, Rajesh. Looking at some more questions. Yeah. So, yeah, what it says is that what I understand is that the machine learning model-based approach requires large data set for training the machine learning model. So, how is this managed using Gen AI? Rajesh, would you like to take that up?
Yes, Sandeep, you explained that part. We are using the synthetic data set generation. The main bottleneck in the AML training is like availability of the defective data sets. And the most often that is going to be destructive. We cannot create a cracked object in the real scenario. But using our tools, we'll be able to generate synthetically created data sets for training our model. Uh, Images and the defective or good images we can create, and that will be effectively used for the training for improving the performance.
Right. Thanks, Rajesh. Do you have any solutions to purchase? Okay, let me answer this question. So we don't sell any solutions yet in the market. What we do is we execute projects for our customers, and based on each customer's requirement, we develop the solution and deliver, and also support our customers for deployment, including support for making sure that it achieves the required production level accuracy. Having said that, yes, we have developed certain solution accelerators, some of which is what I shared in my presentation, and those are used by us as part of our projects to reduce the time and cost of development of asset inspection solutions for our customers. So hope that answers your question. Uh, Yeah, I think I'm looking at some other questions. Okay. Okay, so another question is, can both the GenAI and agentic AI work together in closed loop inspection system? Uh, Rajesh, would you like to take this up?
Yeah, definitely. The agentic AI will be performing as a role of integrator for the GenAI modules, basically for the decision making and branching and orchestration. Agentic AI will be supporting for it,
Okay, so
and even
both
for
can,
initiating MLOps algorithms, agentic AI can be used.
yeah, because agents can monitor the performance of the machine learning models and can trigger retraining as required, right, Rajesh?
Yes.
Yeah. So another question is, how do you ensure that the GenAI models remain accurate over a period of time when the real assets age and evolve?
Yeah,
Raj-
this, yeah, I will answer that part. Basically, the way we are developing the solution, it is not strictly coupled to the, I mean, the objects or models, and it is we'll be able to deploy it with a minimal training. That is something like a zero shot and zero shot learning or few shot learning. Those are the approaches we are following. That is not so sensitive to the variations in the objects.
Okay.
Handle the multiple variants in that way.
Okay. So yeah. So yeah. What you're telling is, with few shot and zero shot approach, even fewer data sets can mean that the GenAI model can handle the variations.
Yes, yes, exactly. It
Yeah.
is agnostic to the variants basically.
Yeah, agnostic to variance, correct.
Yes,
Compared to machine learning model, which is relatively more rigid, if I have to say.
yes,
Is that right?
yes.
Okay. So that is there. Yeah, can a GenAI powered solution be integrated with existing real asset management platforms from the industry? Rajesh would like to take that up. Or
Could you please
maybe
repeat
I'll
that?
answer that if, yeah, I think what it means is, okay, I understand. Yes, so GenAI outputs can be formatted to integrate with, the existing enterprise asset management systems from third-party companies. And I think in this particular role, even the AI agents have a key role to play in terms of integrating this to the various systems to complete a full-fledged system which can work end to end from inspection all the way to maintenance planning. So yes, that will also require integration with IT assets. But yes, the answer is short answer is yes. GenAI can be integrated by giving the right formatting to the outputs to the other subsystems.
Especially through the agentic AI framework.
Yeah, right. Um, I think there is another question. Like, can GenAI deal with this environmental variations in image data like snow, rain, vegetation? Like if there's a rail track with or without vegetation, can a GenAI model
Yeah,
work?
yes, yes. That aligns with our previous answer actually. See,
Okay.
it's agnostic to the variants because variants will be easily handled by our approach.
By a GenAI approach, right? Okay. I think a few more questions are there. Yeah, the question is, how frequently the AI ML models should be trained for detection and classification. Okay, maybe this is not a question for GenAI specifically, it's a question for AI ML, Rajesh. So what would be the factors which requires retraining of the AML models?
Yeah, when you are using the pure AML approaches, then there could be some training requirements based on the changes in the structure, maybe the color, and even depending on the environment, there could be some changes. And periodically, there should be training. Whenever you have the scenario changes, there should be extensive training done. But when you have the GenAI framework, you'll have plenty of data generated through the synthetic approaches, and that can be used for retaining the model and keeping it up to date.
Okay. Thanks, Rajesh. So there's a question that if a company wants to start involving GenAI for application development, if a company wants to start looking at incorporating GenAI for asset inspection, what do you suggest as the approach uh, to start?
Yeah,
Basically, yeah,
anyway,
if somebody wants to experiment with GenAI for asset inspection, what is the best approach to start? What is the best approach, companies can take? That's a question, I think. Yeah.
yeah, anyway, so GenAI-based approaches are slightly complex. It's not so straightforward as the general AML, where we have the data sets available, you are training certain models and using it for inference. But here we need to apply right from the development framework, from the synthetic data set generation and customizing this inferencing model. And there are certain complex areas through which you have to pass through. And you had a slide on that, the development sequence cycles aspect.
Right. Okay. I think, yeah, I think those are the questions, we had, and we have time for that. So with that, we will wind up the presentation. I would like to thank you, everyone who has joined on this webinar from various geographies, and took out time to be part of this presentation. And definitely, Gen AI and AI agents are going to play a much important role as we go forward, with some areas where Gen AI has already started getting introduced. Having said that, as I mentioned in my presentation also, Gen AI and Agents AI, in at least near term, I don't see they will replace the traditional AI/ML with computer vision. But the value which Gen AI and Agents AI brings is reducing the cost and increasing the automation, and thus bringing additional value over and above the existing traditional AI/ML models which work along with computer vision. And that's where I think the focus is going to be, and we shall see more developments as this field is fast evolving. So with this, I conclude my presentation. Thanks again to everyone who joined the webinar. Thank you.